So the idea is simple. I want to somehow measure the power or the thrust of a rocket motor. To do that, I could just use a simple weight scale. Or I can build one myself, and that would be called the Rocket Motor Test Stand. To start building a test stand, I first had to buy some parts, and I just received them. This is an ESP8266 node MCU microcontroller. It may look like an ESP32, but it's not. The ESP32 is much more powerful, but for this project, I don't need that much power. So the ESP8266 is more than enough. It even has Wi-Fi, and you'll see how I use that. This is an HX711 amplifier module. I need this because the signal from the load cell is very weak, so the HX711 amplifies that signal, so the microcontroller can read it. This module sits between the ESP8266 and the load cell, and this is the main part of a weight scale, or in this case, for a test stand. It's a load sensor, also known as a load cell or force sensor, whatever you want to call it. The way this sensor works is pretty simple. One side is mounted on a solid surface like metal, and the other side is free. Whenever we apply a load to the free side, it bends slightly. Inside, under that white plastic, there's a mechanism that converts this tiny movement into an electrical signal. The load cell I have is a CZL882 model, and it's rated for 40 kilograms. I think that's enough because a simple PVC rocket motor shouldn't produce more than 40 kilograms of thrust. As you might remember, I once bought parts with the wrong voltage ratings, and that's the reason I struggled a lot while building the silly flight computer. This small module here is a logic level shifter. It can help if those voltage mismatch problems happen again, but honestly, I don't think I'll make that mistake again. This is a prototype board, and we all know why we use it. But I'm not going to use it in this test stand because the whole setup will be plug and play. I don't even know why I'm showing it. Now, let's test the ESP first. Initially, I thought I would install MicroPython on the ESP, just like I did with the Pico microcontroller. But I found out that it's quite difficult to upload MicroPython on the ESP8266. However, it works well with C++ since it's designed for that. Working with the Pico was much easier. So I downloaded the Arduino IDE and ran a simple LED blink code, and the ESP worked just fine. But I don't really like the uploading system in the Arduino IDE because I can't just run the code instantly. I have to upload it to the microcontroller first, and then it runs. When I was working on the silly flight computer, I used Thani, where I could just press run, and the code would start immediately. It felt faster and easier. However, Thani mainly supports MicroPython, which is why I wanted to install it on the ESP8266. But since that turned out to be too difficult, I decided to stick with the Arduino IDE. I'll use it for this project, even though it might... This setup will be plug and play, so I won't solder everything. Instead, I'll use jumper wires. However, the HX711 module didn't come with pre-soldered pins, so I'll have to solder them myself. I know some of you might not be familiar with soldering, or maybe you're not very confident with it, so I'll explain it in a simple way. First, place the component and the pins onto a breadboard or anything that can hold them in place. Before you start, clean the tip of the soldering iron properly and apply a small amount of solder to the tip for better heat transfer. Now, place the iron on the joint you want to solder and let it sit for about 2 to 3 seconds so the surface heats up properly. But don't overheat it. After that, apply the solder to the joint, then remove the solder first, and finally pull away the iron after another second or two. And that's it. A clean and solid solder joint. In just a minute, I completed all the joints, and now the HX711 is ready to be connected. Now I can test the load cell. Here's the connection diagram. After wiring everything up and connecting it to the computer, the first step is to install the HX711 library. To do that, go to the Sketch option in the top menu. Then include Library, Manage Libraries, search for HX711, and install it. Make sure the ESP8266 is selected, then upload the test code. After that, open the serial monitor, and you should see readings like these. As you can see, whenever I apply some load to the sensor, the readings change, which means the load cell is working perfectly. Now it's time to calibrate the load cell, because without calibration, it won't give accurate readings. Before calibrating, the load cell needs to be mounted properly on a solid surface. So, I made this simple base for the test stand, using some old pieces of wood I found on my roof. I know it doesn't look very professional, but it gets the job done. Since I couldn't directly mount the sensor, I made this small metal plate with 4 holes for bolts. Always apply the load on one side of the load cell and keep the other side fixed, with some space underneath. The arrow on the load cell also indicates the direction in which it should be mounted. Now, calibration itself is pretty simple, but for some reason, it took me 3 days to get it right. On the first day when I tried calibrating, the readings weren't even close to 0. And without a proper 0 value, calibration becomes very difficult. I tried different codes, but nothing worked. I thought the issue might be with the wiring, so the next day I checked and fixed all the connections, but the problem was still there. Finally, on the third day, I managed to fix most of the issues, and the readings started getting closer to 0. After that, I placed a known weight on the load cell and used those readings to calculate the calibration factor. I did take help from AI to generate the final code, since I'm still learning programming. It actually gives me the freedom to focus on building and experimenting while still getting the coding part done. But yeah, I'll definitely learn coding as well. I didn't want to use an SD card to store data, so I decided to use the Wi-Fi of the ESP82 to send all the data directly to my phone. This part was honestly the hardest, because sometimes I couldn't properly explain to the AI what I wanted in the code. Sometimes there was no data on the screen. Sometimes the start and stop buttons didn't work. Sometimes the graph wouldn't show up. And sometimes the whole system just broke down. After spending an entire day sitting in front of my laptop, I finally completed the program. And now it's actually very easy to use. I just need to connect my phone to the ESP's Wi-Fi, open a browser, enter the ESP's IP address, and I get a live graph showing all the data directly on my phone. The program also has start and stop buttons. And yeah, just ignore the tear button. It doesn't really do anything right now. This whole process took a lot of time. I had around 4 to 5 hours of screen recordings, but when I started editing, I realized that the footage wasn't saved on my computer. I tried to find it, but it was gone. Still, I had enough clips to continue. While testing the rocket motor, I don't want to keep my laptop nearby, so I'll power the entire system using 3 lithium cells with a mini 360 step-down converter. The test stand isn't fully completed yet, and I was running out of time, so I'm uploading this video as it is. But I can still show you how I'm planning to complete the motor mount. It's a very simple design, mostly made of wood, but I'll make it heavier and stronger for better stability. The program is ready, and now I'll move on to building the rocket motor. So, make sure to subscribe for the upcoming videos. There's already a lot on my channel. Go check those out too.